Number one, if you're watching this, this is the setup to help you with the fourth activity in this unit, that is finding the center of the Milky Way galaxy. So your first step is you want to go to our website. You want to make sure you go down to Unit 8, Galaxies, and you want to come down to the fourth activity. So that's all the way down near the bottom. You'll see galactic structure, or galaxy structure. In the folder here, you've got 4 things to complete the lab. You've got the center of the Milky Way galaxy lab document itself. You've also got data for the center of the galaxy lab. You've got the NGC cluster images, and you've got polar graph paper. So if you look at this lab, what we're doing is we're trying to locate where the center of the Milky Way galaxy is. You may think that we are the center, but we can do some measurements to actually figure out where we actually are. So your steps are written out right here. You want to measure the size of clusters and record them in a data table. I've filled in a data table for you that is right here. It has the cluster number, it has galactic coordinates of L and B. We'll come back to that in a minute. You've got this cosine of B, which is a math term. We've got the distance to a cluster written here, and then we've got angular size. So what do I mean by angular size? What I need you to do is open the images like this. There are 19 images of globular clusters. What I need you to do is take out a ruler and actually measure this cluster. You can do it right on your computer. You can take the ruler, measure straight across the cluster. Make sure you try to be uniform every single time. But if I measure across the cluster, it looks like the cluster, the densest part is around 2 centimeters wide. So I'll come back to my lab packet here. You want to make sure that you make your own copy. So you want to make sure you go to File, make a copy, and put it into your drive so that I can see your completed work. But once you've got that size, you can just put it right here in the angular size, 2.0 centimeters, and do that 19 different times. The clusters are many, many different sizes and shapes. And please note that if you do look at some of these clusters and notice something odd, like this, there's a lot of fuzziness to this cluster. There's a lot of background stars and a lot of mess going on. There's a couple questions I want to ask you about why this might be. So once you have the entire angular size column finished, what you need to do now is figure out the projected distance to the cluster. What does projected distance mean? It means how far would I have to walk into the galaxy to be right underneath that cluster. Since we can use right triangle geometry here, we actually just need the projected distance along the disk, which is taking the distance that we measured to the cluster and multiplying by the cosine of B, which is just an angle between the disk up to the cluster. So in order to get projected distance, this final column here, it's very, very simple. I take the fourth column here, cosine of B, multiplied by the fifth column here, which is the actual distance to the cluster, 17.4, I get 2.958. That is the distance that I would have to walk into the disk to figure out where I actually am. This is a unit of kiloparsecs, by the way. A kiloparsec is 1,000 parsecs, and a parsec is really just 3.26 light years. So it's another way of just trying to measure distances in space without giving you very, very large numbers. So this cluster is 2.95 kiloparsecs away. Just now, if you noticed, there are actually 6 known distances for clusters. The rest of the distance column is completely blank. So you need to fill in this distance column based on the angular size. One thing we're going to assume with this lab is that all clusters are about clumps of a million stars. And when we look at those clumps, we're going to assume they're all about the same size. So that means if a cluster is big, that's going to tell us it's probably pretty close to us. And if the cluster looks small, we're going to assume it's far away. And what I did with the first 6 clusters is I plotted that data. So the first 6 points here, I plotted out their angular size and distance. And if you look, we got this trend. Small clusters, as you see here on the far left of the graph, are very, very far away, while larger clusters are very, very close to us. Almost all the data matches up with that best fit line for this first 6 points. So I want you to use that information to figure out the rest of the distances. So this is the first cluster that actually doesn't have a known distance to it. And if I measure that cluster, I get about 1 centimeter. I'm going to put 1.0 centimeters for my angular size, but I have to use my graph to figure out exactly how far away this is. So I come to the 1.0 centimeter size, I come all the way up to the best fit line, and I say this is about 23 kiloparsecs away. Continue this for the rest of the clusters. Make sure that you get the angular size and distance based on your measurements and the graph. Then you want to find your projected distance. Once you have all the projected distances, we need to figure out where we are in the Milky Way galaxy. And there's one more tool that you're going to need. Come back to our website, and there's a Desmos tab. You want to click Join. Once you click Join, it's going to ask you either to sign in to Desmos, or you can continue without any sign-in. Just put your name here. And when you hit go, it's going to start the center of the galaxy plotting. What Desmos is going to let us do is figure out exactly where we are in the center of the Milky Way. But this is what you're going to see here. There are instructions on how to plot the points. It tells you which columns to look at. The A column corresponds to the second column in your graph, the L angle, and the R corresponds to the projected distance, that last column that you calculated all the distances you'd need to walk to the cluster. So if you see, I've plotted the first one. The first angle was 333 degrees at a distance of 2.95 from the center. So I'm going to put those two data points into my graph, and what Desmos does is it plots that point. You can see I'm about 1, 2, 3 rings away from the center, so that tells me how far I am from the sun, and I'm at around 333 degrees. Hit this tab again, and you can fill in the rest of your column all the way down. You can manually type in your numbers, or you can use their keypad that pops up. Once you are completely done and all 19 clusters are scattered all around your sheet here, the goal is to figure out where the center of the Milky Way is. To do that, I've included some sliders on this graph. Bring back your data table, and there's instructions. It talks about how to bring out the sliders. There's B, C, and D sliders. D controls the size of your circle, C controls up and down location, and B controls your left and right location. I need you to make sure that you are circling all of your clusters with this blue ring. So figure out where this blue ring needs to be so that all your clusters can be in that grouping. When you've done that, wherever this circle ends up is the center of the Milky Way galaxy. Count how many rings it is to the center of this blue circle, and tell me the degrees, what direction I'd have to go. So that's a step-by-step process of how you find the center of the Milky Way galaxy. Good luck, and ask a teacher if you need some help.